Welcome. So this question says a 4 kilogram particle traveling with a velocity of 2I plus 3j plus 4k meters per second collides with a 2 kilogram particle traveling with a velocity of 2I plus 4j plus 2k meters per second. And then what is the velocity of the combination after this perfectly inelastic collision? So let's visualize it. So here's my particle. It's 4 kilograms and it's kind of going like that, and we'll just write down 2I plus 3j plus 4k meters per second. It's just a schematic diagram. I've got no special information about the actual true way I should represent these vectors. I'm just drawing an arrow for them. And then the next one is a 2 kilogram particle, and we're going to kind of draw these things colliding. And this is 2I minus 4j plus 2k meters per second. And then they collide. And so we end up with this, and they stick together. So we end up with this combined mass of 4 and 2. And that goes off with some velocity v. And that's what we'd like to find. So the key thing to realize, it's a perfectly inelastic collision. And as one of the two types of inelastic collision, then momentum is conserved, but kinetic energy is not. So we're going to say P initial equals P final. And of course our initial momentum is M1 V1 initial plus M2 V2 initial is equal to M1 plus M2 V final. Let's call that V final. Let's just rearrange so we can see the layout. So V final is equal to M1 V1 initial plus M2 V2 initial over, well, M1 plus M2. So what we're saying is that the momentum of the first mass before collision plus the momentum of the second mass before collision must equal the momentum of the combined mass after the collision. Well, I need to keep track of this somehow, so let's just do ourselves a little grid so we can keep track. I find this layout just helps me not make mistakes. And then the first thing I want is M1 V1. Well, let's put this in yellow. There's M1 and there's V1. So we'll work on that. M1 V1 initial. So rather than 2I, it's 4 times 2I, because it's the mass times the velocity. So 4 2s are 8. And then 4 3s are 12. And then 4 4s are 16. So the momentum would be 8I plus 12j plus 16k. And then the next thing we want to do is add M2 V2 initial. And if I look up here, there's my M2 and there's my V2. So I need to put these guys together, and I can say, well, that's going to be 2 times 2 is 4, and 2 times minus 4 is minus 8, and 2 times plus 2 is 4. Now, according to this expression, I need to add these two guys together. So 4 and 8 is 12, and 12 and minus 8 is 4, and 16 and 4 is 20. So that's the M1 V1 initial plus the M2 V2 initial. But if I want VF, I got to divide that by m1 plus m2. So I take this and I divide it by m1 plus m2 is 2 plus 4, which is 6. So this is, I've lost my pen for a second. There it is. So this is divided by 6. So if I put this in, I would have 12i over 6 plus 4 over 6, 4j over 6 plus 20k over 6. And I could actually leave it like that. I could call it, oh, it's going to be a velocity, so it's meters per second. But I can work out my answer to final numbers. So let's go 2.00i plus 0.66j plus 3.33k meters per second. So there's my final answer. And if I look, I can find that somewhere. 2 plus 6 points, there it is. So we just worked out a perfectly inelastic collision using ijk vectors for a three-dimensional answer. So it's really quite, I think it's quite impressive. What did we do? Well, the first thing was we visualized and we wrote down our information. And then we found our principle, and the principle was that the momentum before the collision equals the momentum after the collision. And then we wrote down our expression, and then we rearranged. By rearranging, it told me how to do the problem. So I took the first mass times the initial velocity for the first mass and multiplied that out to get my initial ijk. And I took my second mass, multiplied by the velocity of that second mass before the collision, and I got my second ijk. And because of this operator is a positive, I added those two guys together. And then to get my final answer, I recognized I needed to divide that vector by the total mass, which was 4 plus 2 is 6. So this here is my V final. And I wrote the V final out in fractional form and then in decimal form. There we have it.